we're going to talk about solving right triangles. So we're going to add a couple things, still using SOHCAHTOA. Okay, we're still going to be using SOHCAHTOA. Some of you, I understand, I think, are kind of struggling with when do you use sine, when do you use cosine, when do you use tangent, those type of things. So I'm going to give you kind of a diagram here you might want to copy down to help yourself out. So sine stands for the SO part, and we use sine when we have a right triangle, and we know that angle, and we have those two sides. Okay, that is kind of what it looked like when we use sine, opposite over hypotenuse. Cosine is our ka, and again, if I use the same right triangle, I use cosine when I have the hypotenuse and the adjacent side. So I use cosine when I have the angle in between the two sides. And then we have our tangent, our TOA. Alright, our TOA or tangent for our right triangle is used when I have the opposite and adjacent. So there we have SOHCAHTOA. And again, on top of all your papers when we're doing this, it'd probably be very helpful to write that down. Okay, and again, that is sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. Okay, but there's SOHCAHTOA. Sine is the opposite side, hypotenuse. Cosine is adjacent. And cosine and adjacent is kind of in between there. And then tangent is whenever you do not have the hypotenuse. So you have everything but the hypotenuse, basically. So again, hopefully copying that down can help maybe you visualize and see when you have what you have. Adjacent. All right, so today we're going to be talking about what is the inverse trig functions. Okay, we're going to be talking about inverse trig functions. We can use the inverse trig functions to find the degrees of an angle. So the other day we were using these sine functions. So if you look on your calculator, I want you to look for the inverse function here. It is the sine to the negative 1 power there. It is called the inverse sine function. We have not been able to find it on that calculator today.
Yeah, it's right there. That was really easy. You just click second. Right
just kidding. That was easy. Okay, so you want to find the sine inverse button. When you find the sine inverse button, I'd like you to type in sine inverse of 1/2. So sine inverse of 1/2. And when you type that in, it should come out with 30 degrees.
Where is it?
You want to hit the second button. Oh, wait. So you're going to do 0.5. And then go sine inverse.
Is it on these because it doesn't appear?
Yes. It is on the phone if you hit the second button.
No, on the phone.
So you want to go 0.5. Hit the second button. Then there's sine inverse. There you go.
Cool.
Oh, that makes sense.
Okay. And then hopefully if you did the sine inverse of 0.5 or 1/2, you would get 30 degrees. You did 1/3. You want 1/2. Okay. Oh, gotcha.
Wait, what'd you do?
Sine inverse, you gotta hit the second button. So you gotta do second. Sine inverse. Oh, sorry. 0.5 or 1/2 sine inverse. There you go. Alright, so hopefully you kind of got familiar with it. But we can use the inverse function to find the degrees of the triangle. So when I know side lengths, I want to find degrees, I can use that. Okay? And the same is true for cosine and for tangent. Alright, first thing we're going to talk about is we're going to talk about how to, again, identify sine, cosine, and tangent. So number 1 says, I want to find which one is angle A. Is it 1 or is it 2? I have 2 angles here. Okay, so I have angle 1 and I have angle 2. It says the sine of angle A is 1/2. Well, which ratio of side lengths gets you to 1/2? 3 and 6, right? Now, sine stands for what? In the SOHCAHTOA, what's sine? Okay, so is it angle 1 or angle 2? That would give me to opposite over hypotenuse 1/2.
1.
Angle 2.
Angle 2.
Because it's opposite over hypotenuse. That's angle 2. Okay. Now look at number 2. It says the cosine of A is 13 over 15. Do we have any 13 over 15 on here? No, but I have some decimals, right?
Yep.
How do I get 5.2 rid of a decimal? What do I need to multiply by?
10.
I could multiply by 10, but I'm actually going to multiply by 5, because 5.2 times 5 is actually 13, 30, and 15. Well, that's a little bit easier. So which one gets me a cosine? What? Oh, I said 13 there. That's 26. Thank you. Which one gets me a cosine of 13 over 15? Which one gets me a cosine? Cosine, again, is adjacent over hypotenuse. Which one gets me a cosine that's 13 over 15? Troy? Angle 2. Nice job. Angle 2 would be adjacent over hypotenuse. Give me the ratio of 13 over 15. Number 3. The cosine is 0.5. Well, which angle would give me a cosine of 0.5? Which angle would give me a cosine? Yes, sir?
1.
Angle 1. Nice job. Because that would be the cosine and give me the fraction of 1/2. And then the last one. Which one would give me the tangent of 15 over 26? Tangent, remember, is opposite over adjacent. So which one is tangent 15 over 26? Is that 1 or 2, Drew? You got a 50-50 shot. Which tangent says opposite over adjacent is 15 over 26? It is not 1 because it is actually 2. Opposite over adjacent. I want the opposite is 15, so that means angle 2. Okay. Again, that just kind of helps us identifying sine, cosine, tangent. Using your calculator and your new inverse function, find the angle measures of these 4 sine, cosine, tangent functions. Please round them to the nearest degree. All right, so number 5 here. The inverse, the sine inverse of 0.8 is how many degrees, Jessica? 53 degrees. Nice job. Number 6, the cosine inverse of 0.19 is what, Ryan? Nick? 79 degrees. Oh, I forgot I got 2 Nicks in here now, don't I? Yeah. Number 7, the tangent inverse of 3.4 is what, Bryce?
74 degrees.
74 degrees. And number 8, the inverse sine of 1/5 is what, KZ? 12 degrees. Nice job. Okay. So we're now going to use this inverse functions to find or to solve a triangle. So solving a triangle means to find the measures of all the angles and all the sides of the triangle. Now, we can use trig functions for all this. But let's not forget everything we've already learned about triangles. For instance, the interior of a triangle adds up to what? Okay, so if I have a triangle like this, can I find angle J right away? Yeah, what would angle J have to be? 52 degrees. That's not very tough. I can use that. Okay. Well, I mean, I didn't have to use anything we just learned right there. And I know that angle has to be 52 degrees. Okay, well, I got that angle is 52. Well, let's say a lot of us like to use sine. I don't know why, but sine is always typically everybody's favorite one, just because it's first, I think. But the sine of 38, well, I can use the sine of 38, and I can find JL with relation to 22, because I set up my ratio. And then once I have that, well, I can use sine, cosine, and tangent to find the other one, or I can also always remember to use Pythagorean theorem. Okay? Either way you work these out, there's multiple ways. Okay? You just got to find whichever way is best for you. But you can use sine, cosine, tangent. You can use Pythagorean theorem. You can use the angles of a triangle up to 180. All of them work. So let's try number 9. Number 9 here. What do you notice I can probably solve for right away? What is the first thing I can solve for, Drew? Angle B. What does angle B have to be? 37 degrees. Nice job. Does everybody see why angle B has to be 37 degrees? Triangle's up to 180. Okay. Now I've got to start using some trig functions here, though. What do you want to solve for first? Anybody? Doesn't matter. What? Let's do AB. Awesome. I'm going to do AB first. Well, I know A is 53 degrees. What trig function am I going to have to use for relationship here? I have sine, because I have the opposite is 10, the hypotenuse is x. So I would say the sine of 53 equals 10 over x. So sine of 53 equals 10 over x. What is the sine of 53? Anybody? Go 2 decimals. What is it? Huh? 0.8? 2 decimals is 0.8? Okay, 0.8. And so 0.8 equals 10 over x. Well, now I solve for x here. Now you use what you know, solve for x. What does AB have to be? Anybody? It is 12.5. Nice job. All right. Now I'm going to use the same 53 degrees. And what happens if I want to find AC here? What trig function can I use to find AC if I want to use 10 and x? What trig function would I use there? Who did it say? Tangent. Tangent uses the opposite over adjacent. So I would use the tangent of 53 equals 10 over x. So essentially, really, it's the same work. It's just a different trig function. So the tangent of 53 now. What's the tangent of 53? 2 decimals, anybody? 0.33. What does it say? 1.33, right? So 1.33 equals 10 over x, which means AC has to come out and be 7.52. Nice job. And I did all of that knowing trig functions. Number 10. Now let's not forget here. What type of triangle do I have here? A right triangle. Anytime I have a right triangle, what can I use? Can I use Pythagorean theorem and solve for FH here? You bet. Use Pythagorean theorem and find FH. Okay, use Pythagorean theorem and find FH. Now, do remember, you do have to, last step, take the square root. Okay, always do remember that last step is the square root. Some people earlier today were forgetting that square root. And FH comes out to be what approximately, Nalt? 9.12. All right. Now I have all my side lengths. Now I'm going to have to use one of my new inverse trig functions. I do not care which angle anybody wants to find. Somebody pick an angle. F. We're going to find F. Okay. Now, I have all three sides. I can use any of the trig functions I want to use. It does not matter. I just have to make sure I put the right ratio in there. What trig function would you like to use, Tina? I'll let you pick. Let's use sine. So I'm going to use inverse of sine. So sine inverse of, now sine, what two sides do I use for sine? I use the opposite and hypotenuse. So F, my opposite is 4 over my hypotenuse is 9.12. So go sine inverse of 4 over 9.12. And sine inverse of 4 over 9.12. Round it to the nearest degree, please. And that would get you angle F. Troy? Is it 26 degrees? Sounds right. Now, if that one is 26 degrees, can I find angle H?
Yes.
What would angle H have to be? Troy? Angle H has to be 64 degrees. And in this problem right here, I just had to use one trig function, and I found every little piece about that triangle. Okay. Number 11. What looks to be the easiest to find in number 11 first, Noah? Q. I can find angle Q right away, right? What's angle Q, sir? 34 degrees. Okay, I have 34 degrees. Awesome. Now I need to find my other side lengths. It does not matter to me. Which side length would you like to find first? Jack, which one would you like to find first?
RQ.
Let's find RQ. Well, if I'm going to find RQ, what trig function do I have to use now?
Sine.
Do I know anything about the hypotenuse?
No.
So what trig function do I have to use?
So. Okay, tan.
What trig function do I have to use here, Troy? I have to use tangent here. Okay? On a problem like this, I have to. Why? Because I know nothing about the hypotenuse. I have to use the tangent here. So, which angle would you like to use? It does not matter. Let's use 56. So, the tangent of 56 equals x over 14. Now, that would be the easier one to use, Trevor. Nice job.
Are we still doing like negative?
Nope, that's only for finding degrees. You use the inverse for only finding degrees. So, I have the tangent of 56 equals x over 14. The tangent of 56 is approximately what?
1.42 or 1.48.
So 1.48 equals x over 14. So I take that times 14, and x comes out to be what? 21? 20.75. Thank you. Awesome. Now I need to find QS. Well, I'm going to label QS as x here. I can use trig functions, or what else could I use to find QS? I can use Pythagorean theorem. Either way you work it out, it does not matter. Okay, but I can use Pythagorean theorem or trig functions, and I can get QS. Pick your choice and find QS. All right, Mr. Nault, what does QS come out to be? 25.03. Nice job. Then depending on how you round sometimes, like somebody earlier today was like, well, I got 25.00. Well, depending on how you round, sometimes you could be off like a couple decimals, but that's just with rounding, so you're fine. All right. Last one here, number 12. I have xy is 36 and wy is 31. What can we find first here? We can find a lot of things first. Doesn't really matter. What would you like to find first, Bryce? Let's find wx. What can I use to find wx? Pythagorean theorem. Now, would I add the two numbers or subtract them here? You'd subtract them because I have the hypotenuse. So use Pythagorean theorem and subtract them. So 36 squared minus 31 squared, and then take the square root. So 36 squared minus 31 squared, take the square root, and xw comes out to be
18.3.
is it 18.3? Nice job. 18.3. Now the next part. Now I need to find the angle measures. I can do any angle, whichever one you want. Keegan, which angle would you like to find? Let's do y. Keegan, which trig function would you like to use? Sine. So I'm going to do sine inverse now, because I need to find the angle. So I'm going to do sine inverse. All right. Now, because I'm using sine, what two sides do I need? I need the opposite and the hypotenuse. So I'm going to do sine inverse of 18.3 over 36. So sine inverse of 18.3 over 36. And that gets me that angle y comes out to be approximately how many degrees, Caprio? So to the nearest degree, that is 31 degrees. Okay? And that means angle x is then going to be how many degrees? Troy? 59 degrees. And again, right there, all we had to do was use trig functions once. And I found everything I knew on that. Okay, so we use sine inverse when we're trying to find the degrees. We use sine, cosine, tangent, then we're trying to find the side lengths. All right, take a couple seconds, try both of these. You need to find the missing side lengths and the missing angles. Okay. Number 13. Notice number 13 might be a Pythagorean triplet. It might help you with that. Number 13 here. Hopefully we all figured out. Shh, quiet back down. AC. Tom, what's AC come out to be? 3. Nice job, sir. That is a Pythagorean triplet. 3, 4, 5. Start recognizing those. Makes your life a lot easier. Now angle B. We start angle B right here. Okay, when we know all the sides, you can pick any trig function you want. Most people pick sine because it's first. I don't know, they just do. I can pick any trig functions. You just got to make sure you put in the correct ratio. So angle B, I would do sine inverse of 3/5. And that gets me to the nearest degree. What, Caitlin?
I think I did it wrong. I got 37.
It is 37 degrees. And then angle C. And then a lot of people are like, oh, I really like sine. I'm going to use sine again. Well, that's okay. If I use angle C, what's my sine inverse now? Well, now I do sine inverse of 4/5. And sine inverse of 4/5 gets me 53 degrees. Or some people are like, well, if I know two angles, could I subtract from 180 and find the third angle? You bet. A bunch of different ways. Number 14. What's probably the easiest thing to find on number 14, Kay? What's angle D? Yep. Angle 9, 39, or angle D is 39 degrees. After I have that, well, now I have to use trig functions to find my other sides. What did you use, Trevor? Okay, and what did you get then for EF? That is correct. That would be EF right there, cosine of 51, because we went adjacent. EF over 18, nice job. And then what'd you do for DE, Bryce?
I just did Pythagorean.
And then once you had EF, you did Pythagorean theorem? Oh, great, awesome. What'd you have then? Oh, just. So I think a lot of people had like 13.98. Some people had 13.99. Right there around 14. Again, depending on what you use and where you round, your decimals might be off just a few. That's okay. All right? But great answer. That's great. Yes, on something like that. If it came out to be actually 14, you could. Otherwise, if it says 2 decimals, make sure you do 2 decimals, though.
Oh, well, I just wanted to know.
I think I kind of.
Here is your assignment.